Oh my goodness, what do we have here, Mark? This is incredible. Seriously, look at these colors. This is Perlin noise if I've ever seen it. This is amazing. And we've got color added to it. Quite incredible, if I do say so. It's an array of circles, and each of these circles is running a script. What we're going to do is we're going to save the original position. We're going to label each of these X and Y. So this one is 0, 0. This one is 0, 1. And so forth. So this would be 1, 1, 2, 2, and so on. So you just have to label every single one of these. It's a very painstaking manual task, but it is worth the reward. Y multiplier. This multiplies how far up and down it goes. So if it's at 1, it will go up and down by about 0.5, so half a meter. And if you multiply it by 2, it's going up and down by about a meter. What noise scale does is it's going to scale the distance between these. So if this is 0, 0 and this is 0, 1, we could make it 0.5, or we could make it further even, like 2. And this is what it looks like when you have noise scale set to 0.05. Absolutely gorgeous, luscious colors. Imagine if this was larger, like if you had 4 rows of this. I'm not sure how far you can get with capacity.
Clouds. It's like clouds.
Perlin noise is basically clouds, yes. And so when we are looking at it on an X and Y, what we're doing is we're finding the value of it on a grid. And then our time is basically how fast are we running this. Inside our script, you'll see that we start by setting X to be the X times the noise scale and setting Y to be Y times noise scale. We then set the original position to be the position of self. We then send myEvent, which is just a simple loop. And then we set X to be X plus the number 0.01, so we increment slowly by 0.01. We also do that for Y. Because we wanted it to have a really unique color shifting in hue, we use convert HSV to RGB, getting a new color. The first value is our hue, which we set to be a 2D Perlin noise using our X and Y value. We then set our saturation and value to be 1, so that way they're at 100%. And then our move to is using the new vector from XYZ, with our X being the original position, the Y being the original position plus the value of the 2D Perlin noise, and multiplying by our Y multiplier. So you multiply this and then add it to the original position of Y. And then we do the Z of original position. So that way it's only moving up and down. We do this over time. That's that 0.1 seconds. We run this on self, and then we send myEvent back to self, and it just continues to loop. It's very easy to implement. I highly recommend you check it out. You can find all of these functions under the Operators tab just by scrolling down. You will find 2D Perlin noise, and you'll find new vector from XYZ. And I think it's worth noting that if you grab 2D Perlin noise and plug it in, what you're seeing here is that you plug in the X and Y value, and what it's going to return is a value on the grid. This is incredible. I cannot believe how easy this was to set up, really. I mean, there's a lot of manual labor putting like the numbers in, but other than that, this is how all VR dance parties should look. So thank you guys so much for joining us. If you have any questions, don't hesitate to ask, and look forward to seeing you in the next one. Bye!